Next up, we have Dr. Tanya Harrison is going to moderate the panel about the world is going to Mars and all about international science missions. Dr. Tanya Harrison calls herself a professional Martian. Over the past decade, she's worked as a scientist and in mission operations on multiple NASA Mars missions, including the Curiosity and Opportunity rovers. Her specialty lies in geomorphology. Yeah, that word. Geomorphology, the study of a planet's evolution based on its surface features. Before Mars, however, Tanya had her head in the stars as an astronomer studying the metal content of star clusters and recurring novae systems. She holds a PhD in geology from the University of Western Ontario, a master's in earth and environmental sciences from Wesleyan University, and a Bachelor of Science in astronomy and physics from the University of Washington. Tanya is an advocate for advancing the status of women in science and for accessibility in the geosciences. You can find her prolifically tweeting about the Red Planet and her experiences with both women in STEM and disabled in STEM as @Tanya of Mars. Without further ado, the lovely and wonderful and author of For All Humankind and many others coming up. So take it away, Tanya.
Thank you so much, Janet, and thanks everybody for joining us today. So we have a fantastic panel here, and we're going to be talking about international Mars science exploration. On the panel today in person, we have Dr. Lori Glaze, who is the director of NASA's Planetary Science Division, and we have Dr. Tim Haltigin, who is the senior mission scientist for planetary exploration at the Canadian Space Agency. And then joining us virtually, we have Sanjay Vijendran, the Mars strategy team leader and future Mars studies coordinator from the European Space Agency, and Masaki Fujimoto, the Deputy Director General of JAXA. So we'll start with an overview of the current science activities that each agency has and kind of the look into the near future. So Lori, do you want to explain what NASA is looking at when it comes to Mars science?
Sure, yeah, I'd love to. Thank you so much, Tanya. And if I could have my slides up, please. I've got a couple of graphics I wanted to share with folks as we're chatting here. So hopefully we can pull those up. Go on to the next slide, please. So of course, NASA and the international community as well have really kind of upped our game over the last many years in trying to explore Mars and understand not just for science purposes, but understanding the environment and the habitability of Mars. In fact, over the last 20 years, you can see on this chart, just as focused on study since 2001, focusing on trying to understand the environment of Mars and understanding the habitability of Mars, and then understanding where we might find potential evidence of whether or not life could have taken form on Mars in the past. And so you see that evolution from the orbiters, most of which are all still working, I believe. And you see not just the NASA missions, but those led by international partners. And so a really fantastic effort there that's leading us now to the point where we think we have enough information that we can actually look for those signs of past life on the surface of Mars, and we'll talk about that in a second. But I wanted to also just mention while I'm on this slide that a lot of these assets are still going strong. I mentioned the orbiters are doing really well. I would just point out that the Curiosity rover is also still doing great things on Mars now, almost 10 years on after landing, still exploring in Gale Crater and making great discoveries all the time. The InSight lander, of course, is also still operating and doing great things on Mars. Just recently measured the largest quake it's seen in 3.5 years being on the surface of Mars, estimated to be a magnitude 5, which is probably the biggest thing we could imagine occurring on Mars. And there was actually a telecon yesterday talking about how InSight's power is starting to really drop because of the dust accumulation on the solar panels. And so ultimately it will succumb to the environment on Mars, but what an amazing mission InSight has been. And then of course, if we go on to the next slide, talk for a moment about Perseverance rover. Perseverance now has been on the surface of Mars over a year and has been exploring Jezero Crater. You can see on the top there are wheel tracks as we look back to where we've been in Jezero Crater. We've been spending the last year really trying to understand the environment in Jezero Crater that was present when those deposits were laid down, trying to understand the presence of water in the crater. If you can stay back on that slide, thank you. And also understanding the geology of the crater, hopefully being able to collect some samples of perhaps some volcanic rocks that'll help us date the age of the crater. But looking ahead, at the bottom image, you can see us looking towards the river delta, and of course this is the ultimate goal. The rover has now spent the last month or so doing a rapid traverse to get around a rough terrain area. You can see some of that rough material, trying to come around to that river delta, because this is really the spot we want to be to look for those signs of past microbial life. And in this time, as I said, on the crater floor, and as we now start to work our way up through the delta of materials, also collecting samples in addition to doing in situ science, with the ultimate goal of bringing those samples back to Earth. And I know you heard from Jeff Gramling and others yesterday about Mars sample return. I'll speak just very briefly about that in a moment. If we can go to the next slide. Of course, riding along with Perseverance was the Ingenuity Helicopter. Ingenuity, what an incredible, incredible technology demonstration that has been. A year ago, demonstrating the first ever powered and controlled flight on another planet. And then I love this picture. This one just gives me chills, where we actually spotted the landing system, the back shell and the parachute that were part of the whole entry of Mars 2020 Perseverance. And we sent the helicopter over to take these pictures, and it just makes it so tangible that, here's how we got there. I love it, and we can learn from these as well. Next slide, please. And as I said, the whole purpose of collecting those samples is to eventually bring them back here to Earth, where we can analyze them in our laboratories here. The full capabilities of the laboratories we have on Earth, the laboratory instruments we haven't even thought of inventing yet, save those samples for additional analysis in the future by scientists around the world. So just couldn't be more excited that Mars Sample Return is really going forward in a big way now, completing their Phase A activities, looking at the various trades for the architecture, and preparing to actually move into that next phase of formulation. Next slide, please. We also want to talk a little bit about the preparations for human exploration. Mars 2020 carried several technology demonstrations to help us better prepare and think about paving the way for human exploration. I'll just mention a couple of them on here. The MOXIE experiment, which many of you are probably aware of, has worked really well at demonstrating the ability to convert carbon dioxide to nearly pure oxygen, nearly pure O2 that would be breathable, which is fantastic in preparing for future in situ resource utilization. The Sherlock instrument, which is one of the science instruments on Perseverance, needed calibration targets, and so they brought spacesuit materials and face shield materials that can be observed throughout the lifetime of Perseverance to understand how they respond in that environment at the surface of Mars. And I'll just go on. I know I need to wrap up, so let's go on to the last slide. Thinking about the future, for planetary science, we asked the national academies to conduct a survey every 10 years, a decadal survey to tell us what our priorities should be for the coming decade. And one of the things that I think is really exciting about this decadal survey, it was just released on April 19th, but it explicitly discusses the importance of human exploration and how human exploration can work closely and should work closely with Mars science and with lunar science as well in the Moon to Mars efforts. So really trying to bring those together. There's a whole chapter in the decadal survey dedicated to human exploration. So we're really excited about that as well. And with that, I'm going to pass it on. And I didn't mention MMX. I know that Masaki's going to talk about that. It's a great collaboration, so I'm going to leave that for him. Go ahead.
Actually, we're going to switch to virtual, and then we'll come back to Tim.
Sounds good.
So let's hop across the pond to ESA. Sanjay, do you want to talk about ESA's plans for Mars science in the now and in the near future?
Thank you. Good morning to everyone over there. Sanjay Vijendran here from ESA. Could I have my slides up, please? So I'm going to, Laurie is always a tough act to follow on Mars exploration in particular, but I'm going to do my best to tell you a little bit about what we're doing right now, but more on what the future outlook is for the 2030s that ESA has been working on developing a new strategy for exploration. And I'll focus, of course, on the Mars exploration aspect for today. So we have our exploration program has been rebranded as the ESA Terra Novae, New Worlds Program. 2030 Plus Exploration Strategy Roadmap is something that we've been working on for the last year and published in December last year the first look at what this roadmap might look like. And we're expecting to finalize that during the course of this year, giving the way forward for all three destinations that are part of our exploration program: low Earth orbit, Moon, and Mars. So next slide, please. So for the last decades, and in particular the decade that we're in now up to 2030, ESA's exploration program for all three destinations has been one that has been characterized very much by learning to work internationally and finding our place in the exploration framework internationally. Making contributions to the ISS, as we've been doing for quite some time, and now working very closely with NASA on the next stage of human exploration to the Moon with the Orion, the European Service Module, and the Gateway. And on Mars, we've been leading a Mars exploration mission, ExoMars, for quite some time, working with Roscosmos. We launched the ExoMars Orbiter, which has been operating around Mars for many years now, very well, continues to do so. And as you probably heard, with the ExoMars rover, we were hoping to have our first rover on the surface of Mars, drilling underneath the surface next year. It was supposed to be launched in the summer, just after the summer of this year. That's not going to happen now, and we're in the phase of reassessing what the launch options are for ExoMars in the rest of this decade, and hopefully we'll be able to report out about that in the next month or so. Nonetheless, we're working on the next big thing on Mars sample return for Mars in Europe, which is Mars sample return together with NASA, contributing the European return, the Earth return orbiter, and other surface elements as well. And this is the big program for Mars after ExoMars that's going to take us right up to 2030 and early 2030s timeframe until when it's completed. So the strategy has been really looking at what we're going to do beyond 2030 up to the 2040 timeframe, where we think we are, and we will be entering that era of human exploration eventually. And just to recall, in case you're not familiar with, on the European Space Agency side, the Mars exploration program sits in the wider human and robotic exploration program. So it's an integrated program for all three destinations of LEO, Moon, and Mars, with the long-term goal for Europe to participate in an international Mars exploration, human Mars exploration mission. So what we're doing in low Earth orbit, at the Moon, robotically at Mars in the future, up to human exploration, are all supporting this long-term goal to get humans to Mars, with the robotic missions being used as precursors to gather the scientific knowledge, prepare the technologies that we'll need to eventually reach that long-term goal. So as we move into the 2030s, our strategy now is evolving in terms of how we view partnerships, what our role is as a leader in some areas in exploration at the three destinations, and trying to increase that pace of discovery through a higher cadence of missions that we hope to do at the Moon and Mars in the next decade than we've been able to do in the last couple of decades. Next slide, please. So here in all its glory is our exploration roadmap for the 2030 plus period that you can find in the ESA Terra Novae strategy published at the end of last year, showing how we see the future for European exploration in terms of missions that we may do at all three destinations, but also how they integrate with each other so that we build on what we do and learn at one destination in preparation to move further out to the next destination. So really integrating our strategy across the three destinations so that we maximize the technology development feed forward and the knowledge feed forward as far as is possible between the destinations. And on the top of that chart, you can see there in red what our plans are for Mars exploration, the missions on a sequence, trying to utilize every opportunity for either an ESA-led mission or a mission of opportunity where we may contribute in a small way to partner missions. Starting, for example, with with a nearer term contribution to Mars IceMapper mission would be something of interest to Europe in support of future missions that would come after that. Next slide, please, and I'll speak a little bit more about details of these missions that we foresee in the 2030s that are important for Europe and its goals. So in the middle of this chart, you can see the sequence of strategic missions that we have identified, which are matching the European priorities in terms of science and technology that we want to build up, leading up to potential roles we might play in the human exploration era, eventually in the 2040 plus timeframe. So the first mission that we foresee early in the 2030s would be a communications and navigation network mission. We think this is an important infrastructure to put in place to support not just European missions, but also international partner missions. As the cadence of missions and the interest in Mars grows in the future, we will need more communications and even navigation capability to enhance the science and operational capabilities we have. And then later on in the 2030s, the first flagship surface and orbital mission for Europe would be a weather network. So a comprehensive network of landers as well as orbiters working simultaneously to fully understand and monitor the climate and weather around Mars in a way that's not been done before. Really as a preparation for human exploration to understand how the wind cycle is, how the dust storms originate, which could have operational implications as well. So a really really large but interesting mission that could be split apart between a number of partners if necessary because of its very modular nature. Coming after that, and something that would respond to an earlier orbital mission that would map ice from orbit would be a ground truthing lander mission to actually get down to where we've discovered ice from orbit and drill down and access that ice and understand both confirm its existence and understand its depth and its nature of that ice and the material above it, and even attempt to do in situ resource utilization on that ice as a demonstration for eventual applications for human exploration in the future, to produce propellant, to produce consumables. We see this as a very important preparatory step, not only to confirm where the resources are for future human missions, but to show that we can actually use these resources in a useful way for the future. And then finally, towards the end of the 2030s, we could see an advanced astrobiology rover from Europe pushing the state of the art in astrobiology, but at the same time, using that opportunity to advance the capabilities for entry, descent, and landing towards those that we would need for human exploration in the future. So we know that we need to land much higher payloads to support human exploration. We will need to use different types of entry, descent, and landing technologies than what have been used historically for smaller missions, and this would be an opportunity to extend that state of the art. Now, alongside these strategic missions, we see also a role for small and fast-track missions to complement these larger missions and to increase the cadence of opportunities of flights to Mars. And so a series of regular, small and fast missions is something we foresee and are promoting in Europe to be able to do complementary science, test new high-risk technologies, and develop the capability to do certain types of missions in a much more rapid way than is typically done for the larger missions. And I think with that, we can go to the next slide, and I'll end with just a nice visual on the weather network concept that I mentioned, and say look forward to this conversation about the future of Mars explorations internationally. Thank you.
Great. Thank you so much for that fantastic summary. Masaki, let's hand it over to you. Can you talk about JAXA's plans for Mars science?
Yes, can I have my slide up, please? Yes, we just had Habitability returning the samples back to Earth from Ryugu. And this slide is showing you how the Habitability spacecraft pitched its sample return capsule back to Earth. And then the next slide shows that the capsule was running across the sky and then landed safely on the ground in Woomera Desert in Australia. we managed to do the triangular observation of the trajectory of the capsule, deduce the landing spot correctly, and then send the chopper to the site, pick the capsule up. And when we send it back to Japan and open the sample container, what we found is the big catch, as the next slide shows. So on the left-hand side, you can see that, we have got the big quantity of samples coming back from Ryugu. And the right-hand side shows that the quality of the samples was superb. With this sample, by analyzing these samples, we can really decipher the process that made our planet habitable, water delivery process that was necessary to make our planet habitable. So next slide, please. Harvester, that was a big success. We can tell for sure, we can really be proud for sure that this was a big success. And what do we do next? One way to think is that maybe we are leading the world's effort in small sample return for small bodies, so we should continue that line. And indeed, that's what we are doing. It's a mission by the name MMX, Martian Moons Exploration. We will return samples back from Phobos, one of the moons of Mars. The planned launch date is in 2024. Samples will be returned in 2029. Big support from NASA, ESA, and CNES, French Space Agency, and DLR, the German Space Agency. So it's a full international collaboration mission to bring samples back from Phobos, a small body. But at the same time, we think this has a Mars exploration flavor. If you go to the next slide, it's going to be the first round trip to Martian system. It's going to land and do the sampling on the surface of Phobos, which possibly includes samples ejected from the surface of Mars. So MMX has a flavor of Mars exploration. And I think this is an important element of MMX mission because we think, as the next slide shows, JAXA had been thinking that we were, how do you call it? We were late. I mean, we were not part of the Mars Exploration Club. And as you have seen from NASA and ESA presentations, things have really developed in that club. But with MMX, it's a nice step. It's a nice precursor for us to join the club. And of course, we all Japanese scientists who was interested in Mars exploration, they really like the concept of Mars sample return mission, of course. But on the other hand, it did sound like somebody else's business. But with MMX, led by us, the Japanese Space Agency, now the Japanese scientists are really starting to think seriously about contributing to the Mars sample return mission as the project by humanity or something, as a global effort. So that mindset is really, really important, I guess, to make the Mars exploration, human Mars exploration, as the global effort. And maybe it's not only Japan, JAXA, but some other countries who can participate in that effort more seriously once they have some nice precursory step. And MMX has been really, really nice to us, and we managed to push MMS up to this stage thanks to help from NASA and ESA and other space agencies. But maybe we should think about helping somebody else who, with that help, who might jump into the Mars Exploration Club. So that's something that ringing in my head while I was attending the discussion of Mars IceMapper mission, which I think Tim will talk about in the next talk. But yeah, that's all I have to say. Thank you.
Thank you so much. I know we're all very excited for JAXA to join the Mars Exploration Club, and it's really amazing to see how you've built upon your success at small bodies to take that and apply it to future Mars exploration. So really, really looking forward to MMX. Tim, do you want to take us through what Canada is doing?
Sure. So good morning, everyone. Isn't this exciting? Think about what you're doing today and where you are. You're sitting with 100 colleagues all together in the same place for 3 days, talking seriously about what it's going to take to put humans on the surface of Mars for the first time. So, I think what we've heard so far is individual agencies talking about different strategies and different mission arcs and all the wonderful things that we want to do. But I think we all know that if we're going to Mars and if we're going to put people on the surface of Mars, we're going to be doing this together. And so what I want to share with you today is some of the work we've been doing in terms of how do you take a truly international approach to planning a mission like this. What are some of the data sets that you're going to need ahead of time? And how do you really take different countries, bring them together, and try to make a mission out of it that'll help us prepare to get humans there for the first time. So next chart, please. So the International Mars IceMapper mission is a concept that we've been working jointly for just about 3 years now. And so you've heard it mentioned, I think, in each of the previous talks. Now, this is a mission that ultimately is there to say, well, as the name would imply, where's the ice, right? This is going to be important not only as a resource for humans for consumption, but also for production of rocket fuel to get home. And so understanding where ice is just under the surface of Mars is going to be crucial to make sure that we can safely get humans there and back. And so, the need for ice and the need for identifying that ice has been, mentioned throughout the strategies of many countries throughout the world, and also this need to eventually send humans to Mars. And so what we've done is we've been working on a concept for, like I said, 3 years now. It's been 5 agencies working together very, very closely. The Canadian Space Agency, NASA, OSSI, the Italian Space Agency, JAXA, and most recently the Netherlands Space Office. And so what we're trying to do really is to understand, listen, we all know that budgets are limited around the world. How do we maximize and leverage the capabilities of international agencies, and how do we really build those relationships to make sure that we're ready to go forward to Mars? So next chart, please. So just a bit of background on the payload itself and on the main payload of the spacecraft. This would be a synthetic aperture radar that would be capable of doing, anyone familiar with SAR images, the nice, beautiful 2D images of the surface, helping you understand not only what's at the surface, but under it. And would also be able to operate in nadir sounding mode, so sort of the pizza cutter radargrams that we're familiar with instruments like MarsX and Charade. And so we've been working in Canada on this concept for now 6 years. So we've had multiple industry studies, academic studies, international science teams put together to really tailor the instrument concept so that it would be perfectly designed to really look for that accessible ice in that upper 5 to 10 meters. So where's the ice reserves that we would be most wanting to access with humans? But what we've done now in terms of the international approach to this, we really wanted to make sure that what we were designing is exactly what's needed. And so late last year, we put together an international competition wide open to scientists around the world to populate something called a Measurement Definition Team, or MDT. So this was wide open. It wasn't just restricted to the partner agencies. This was open around the world, and we've managed to put together a team of roughly 50 scientists representing, I believe, 11 countries that, backgrounds in planetary science, in human exploration, in EDL, in ISRU, and all sorts of things. And what we've done then is task them for 2 things. One is to make sure that we understand the questions we need to ask and the measurements we need to take to prepare for human exploration. And second, to look at some of the amazing science we can do. So next chart, please. So I'm obviously not going to go through this line by line. That's not the point. The point here is really, what are the big picture questions? We're starting to really come down, and it's not just, yeah, we want to send people to Mars, but it's truly now, what do we need to know before we go? And so we've broken this out into multiple different categories. So where is the ice? Fundamental questions. Where is it? How much of it is there? How thick is the deposit? How wide is the deposit? How pure is the deposit? Really characterizing that ice in locations where we can feasibly put humans down. But what's interesting, and what the name doesn't imply as IceMapper is it's also crucially important to understand what's on top of the ice. What is the characteristics of the shallow subsurface, the overburden? Because not only are you going to have to drill through it, so you need to know how strong it is, how rough it is, things like that, but this is also the surface that in principle, not only are you going to be landing massive vehicles, you also have to take off. And it's a lot easier to take off from Earth with nice prepared launch pads and things like that. But for the first time we're bringing people back from Mars, there's not going to be that infrastructure. So we really need to characterize the geotechnical properties of the surface and shallow subsurface to make sure we can get down and back up again. Accessing the ice then is not only important as a resource, but obviously for science. It tells you about the history of the climate on Mars, potential questions about habitability. And so just being able to access that ice and use it for science purposes is important as well. So we'll go to the next chart then. So again, not a line by line, but an eye chart. And the point here is that yes, it was very focused on reconnaissance. What is the information we need to do or we need to have before we can safely send humans? But while we're there, we've got a beautiful orbiting vehicle with an incredible payload that can do decadal level science. So Lori mentioned the decadal earlier. So the big questions in planetary science. And so what we've done also as part of this team is really define the science investigations, the pure science investigations in terms of atmospheric and climate science, obviously geology, and questions about habitability as well that are tied not only to the decadal in the US, but to the strategic scientific priorities of the countries around the world. And so really what we've done is we've taken this international approach, priorities from around the world, and condensed it down into how can we do this together and what are the questions we want to answer together. So next chart, please. So bottom line, the takeaway here is I think that if we're ever going to send people to Mars, it's pretty clear that we're going to need to send a radar mission ahead of time to characterize the ice and the overburden and do some incredible science while we're there. It's true there may be other measurements that are necessary. The team has also come back recommending perhaps a lower frequency radar that can see a little bit deeper or high resolution imagery just to help us characterize the landing sites. But we need to remember, I think, we're not just going to send one mission and then send people. This is going to be a tiered approach, right? So what we've done here is really tried to define what is that first step we need to take. What are the first sets of measurements we need to take in order to refine the questions we need to ask to get people there safely afterwards. So thanks very much.
Thank you for that. So you're talking a lot about the science questions we need to answer in terms of ice. Are there any other big science questions that we need to answer about Mars before we send humans?
Wow. Well, I mean, yeah, of course. No, that's the reason. Exploration, I mean, it's interesting because I think the last 30 years of Mars exploration has been very much what do we want to know about Mars? And slowly we're transitioning into a period of what do we need to know about Mars? And as we're working through that, obviously there's the big picture questions, just fundamental questions about Mars. How did it form? How has it evolved? And so understanding past climates, past geological processes, and understanding, in fact, how the ice was emplaced is a really important question because that's going to tell you, give you clues about potential habitability, what might be in there, and ice purity. And obviously the habitability question as well, right? I mean, that's, part of the reason that Mars has been such an exciting target for so many years is really, through NASA missions and others, we've made it pretty clear that it was once very, very habitable. And so the question now is, was it habited?
Yeah, and I'll just kind of build on that a little bit if that's okay. I mean, I think that's another big science question that we need to answer. Hopefully before we send humans to Mars. Right now we don't think that the environment is conducive to life being present today because of the cold and dry and radiation environment. However, the conditions were favorable in the past, we believe, for potential for life to have taken hold for long enough that life could have taken hold. And so, I think getting those samples back as part of Mars sample return is going to be a really important step, although, it's a very low probability that there's active life there now or extant life there. It'll be critically important to understand whether or not life was there in the past and whether or not those environments could still sustain anything there today. So I think that's going to be a really, really important science question that we need to answer that will help better inform how we explore as humans.
Yes, Sanjay or Masaki, do you have anything you want to add to this question?
Sure. So another aspect of more using science to understand the environment of Mars better, to prepare for humans, is this issue about climate and particularly weather. So in the past, we've studied from orbit and the surface a lot about Martian climate over the long term, and trying to understand what the climate was in the past, how it's changed to the climate of Mars today. So how do we go from an Earth-like climate into a cold and dry climate that it is today? That was interesting from a planetary science perspective. But now we start to look towards how can we really understand the weather? How does the atmosphere change in a short time scale that is important for humans to understand, both from an entry, descent, and landing perspective? How do we design the vehicles to be robust to winds and storms and things like that? But operations on the surface, how can we predict when a dust storm might suddenly pop up before we send astronauts out of a Mars base? So weather monitoring, putting systems in place, having the models to predict the weather is something that is going to be quite new for Mars exploration. We find it a huge challenge already on the Earth, but we've got fairly good at it. We need to apply these things to Mars. But in order to do that, we first need to learn much more about Mars. We need to do a lot of weather, climate-related science still that will then help us put the systems in place for humans operating successfully on the surface.
Absolutely. Masaki, did you have anything you want to add?
Yeah, I don't want to make it sound very conservative, but because I'm attending the COSPER Planetary Protection Panel meeting next week, and one of the topics is this human Mars exploration issue. I think I have to point out that planetary protection issue is one of the hurdle, or whatever you call it. You know, one of the things that we have to take seriously before we send humans to Mars. And again, I don't want to make it sound negative. I don't want to make it sound very conservative, but it's really, you know, Mars is really like a, what's the word, national park or something, you know, something that you need to preserve in one way or another. So yeah, I don't think we have the answer yet, but this is something we have to keep on thinking seriously. Yeah, that's my comment.
Fantastic. So I'd like to open it up to the audience if anybody has any questions. There's some mics at the front here so folks online can hear. Does anyone have any questions for any of our panelists? A shy room this morning?
What is the relationship now with China and Russia? What kind of things you can still collaborate, and what kind of things you may never collaborate on?
I'll speak for NASA first, and so we are continuing collaborations with Russia, particularly on the International Space Station, and that's still ongoing. As far as collaborations with China, there are legislative restrictions on the types of collaborations that can happen there. So we do what we can within the laws.
Okay. Did you have a question?
We have a couple of students. Would you guys like to ask
sorry,
your
I couldn't see you
questions?
through the lights.
Hey, I was wondering, why is nothing being done about the Ingenuity rover losing power? Like, couldn't they send something to like clean it, or add like an upgrade where the robot could clean the solar panels itself?
Okay, it's a good question, and I'm going to just ask for a little clarification. You said Ingenuity. Are you concerned about the Ingenuity, the helicopter power, or the InSight lander power? Both of them have power challenges right now, or both.
Yeah, sorry, I meant InSight, my bad.
InSight, yeah, no problem. Yeah, that's a really good question. And so let me just take that from a couple of different angles. So the InSight lander, as I said, dust has been accumulating on the solar panels over the last 3.5 years. And now the power that it can produce is about 10% of the power that it had when it first landed. So just to kind of reframe this a little bit, when we design these missions, we focus on getting the most science we possibly can out of the mission. And in order to do that, we like to take technology that's already been used in the past and use it again. So that means we can spend most of our resources, our money, on the science instruments and getting the science data back. And so with something like InSight, they actually chose those solar panels specifically because they've already flown to Mars on another lander earlier, the Phoenix lander. And so those solar arrays had been tested, they worked, they did great. So that allowed the science team to say, I don't have to develop new technology, I can just bring this lander to the surface. So at this point, that's why they were chosen. It only had to last for 2 Earth years. 1 Mars year was the primary mission for InSight, and it did that. And we've actually gotten another 1.5 years of bonus science out of it. We got more than we needed to, and we've gotten an incredible amount of science data back. But the idea, the question of, well, could we send something there to dust it off? That would take a very long time. By the time something got there, it would have frozen. It needs the solar power in order to power the heaters that keep it alive. And so once it gets too cold, and it's now getting shorter days on Mars and colder, it's going to be very cold, and it's unlikely that it would be able to be revived after that point. But I don't want to be a pessimist, because I think we can learn a lot from this. InSight was really clever. They found a way to they have a scoop that was used to deliver the seismometer onto the surface. And they used that scoop at one point to pick up some of the dirt on the surface of Mars, and then kind of drop it. And as the wind blew that dirt across the top of the solar panels, it actually picked up and cleared some of the dust and allowed them to get a little extra life out of the solar panels. So we know there are ways to do that, and I think we're now thinking, I'm sure, I'm looking over here at Dave Morrow, who works for the company that built the InSight lander at Lockheed Martin, thinking about how can we better design our solar arrays so that they not only give us the power that we need, but what can we do to keep them clean in the future. So hopefully that answers your question. Yeah.
Cool. And did you have a question as well?
This is a question for all of you. Are you planning to make collaboration with countries that just started space missions and just started space agency and are going to collaborate with them, such as India and other ones?
Let someone else go first.
Sure. So no, it's a great question. It's what we're learning, and as we've learned in Mars exploration over the last 30 years that we've been doing it, is that we work better when we work together. And so I think nearly every mission that's flying right now and is planned to fly has some element of international teams in different countries working together. And the combinations of different countries working together has increased incredibly as well. And so I think this is important for a number of reasons. One of them is that obviously you're stronger the more teams you're working with, and so just building that collaboration makes the missions better. But it's also incredibly important for some of the smaller agencies that maybe aren't able to do full missions by themselves. Space missions are hard. They're tough to do, and so you can't necessarily just do one right from the beginning and do it perfectly. And so learning as you go and being part of a bigger mission helps you as some of the smaller and newer agencies get some of that experience to get better at what you're doing, so that the next time you can do something bigger and maybe something bigger and maybe eventually lead one of your own missions as well. So yeah, no, teams are working together all the time.
Cool. And do you have a question?
Go ahead. Hi, so my name is Adila Peterson-Mott, and I have a question for Sanjay, because I'm an Italian citizen. And on your presentation, you had the astrobiology rover, and you said that it would be launched in the late 2030s. And then after the rover came the humans. So has ESA got plans to launch humans to Mars still in the 2030s or early 2040s?
Thanks very much for the question. So our robotic missions in the 2030s are seen as what we as ESA should do to prepare the capabilities for human missions, which for the purpose of the strategy development exercise that we just completed, we assumed the human missions would not happen, and we're talking about an international collaboration between many countries and Europe, before 2039 or even 2041, just into the 2040s. So about 20 years from now. Now you could argue some people are more optimistic about that. It might happen earlier, others more pessimistic. But that for the purpose of the strategy exercise, that was what we thought was a credible assumption. So the missions we laid out would get us to the end of the 2030s with the robotic missions, and then from around 2040, we would expect to participate in the first human mission to Mars, orbital or landed, and then support the human Mars missions that would follow with robotic elements as well to help build up the capabilities on the surface for sustained human exploration of Mars.
Thank you very much.
So just a quick one about dust. It seems like after sort of thinking about Mars missions for a long time, maybe I'm imagining this, but it seems like the dust storms that we know kind of come in the winter, it seems like they're getting worse. And now we're planning around them, like with sample return, in a way that we didn't used to plan around them. We used to talk about opacities of 0.2 to 0.5, and now we're talking about opacities of 10. I'm wondering if the science community is sort of seeing or thinking about like a super cycle, like solar flares kind of, maybe there's some 10, 20-year cycle of solar storms. Do we know that sort of thing? Are we theorizing about it? And then, because this is humans to Mars, how would that impact any planning for an eventual human mission to Mars?
So I don't know, Tim may know more about this topic than I do, but I know that there are some scientists out there that are looking at those cycles. And I'm probably going to speak in a little out of my comfort zone here, but I know I've seen some work that show there is some periodicity in the intensity. We've got now a few decades of data where we've seen both ground-based and space-based of the global dust storms and the frequency. I don't know that we have enough information yet on to say that there's any kind of a increase, but at least looking at the periodicity of those global dust storms. So I think we are going to need to start thinking about those things more, right? And it's a great science area to be studying and to try and understand what the drivers are. And like I said, Tim, you may know more than I do in this area.
Or I may not. But no, but I think what the question highlights, though, is really this need for science questions to answer practical questions, right? And especially as we're gearing into this future, like how are we using what we know to plan for what we're going to do? And so this is going to be important for future robotic missions, and as you say, for future human exploration missions as well. So this highlights, things like Sanjay was saying. Understanding climate is not just, climate and weather are not just questions of curiosity anymore. They're questions of practicality. And so understanding not only when is it safe to put people down, but can we start predicting these things is going to be really important as well. So building up these networks and building up this understanding is going to be, of course, we're going to publish wonderful science papers on it, but then we take that information and feed it directly into some of the mission planning.
Awesome. Thank you very much.
Thank you both so much. My name is Nani Surprise. I'm a PhD candidate at Georgetown University. So my question really falls more on the side of, what are besides collaborations with other governments, we have SpaceX now, we have corporate entities, and all of those aggressive timelines that we're hearing about, which naturally probably, 2027, and there's just talk from Elon Musk about different ones. I kind of wanted to hear a little bit about maybe all of your perspectives in regard to how is the corporate and government, timelines tying in together, and what does collaboration at that level look like?
Who wants to go first? Sanjay, did you want to say something on that one, or from the ESA side?
Okay, I'll have a go at that first. So with regards to timelines, of course, the private sector has big ambitions these days, announces ambitious timelines, but then also differs on pretty impressive timelines in some cases compared to typically what the government has done. So I think the answer is usually somewhere between what government-led programs might predict they can do and what the private sector are saying that they're aiming to do these days. And with regards to how we might work with them in the future, for sure, the capabilities that they are developing in the private sector that we see that are applicable to exploration these days are really impressive. And I think this is going to push forward the capabilities of the government sector utilizes in the future for things like Mars exploration. And that's going to benefit the pace and even reduction of costs of what government does in the future using these new capabilities. And as for how partnerships might develop, that will depend on the mutual interest that there may be for exploration between the private and public sector. And that's also different between destinations.
Yeah, and I do want to say a little bit about it from the NASA perspective, because I think, yes, partnerships are kind of the more traditional way we've done this and working with industry in the past, but I think we're on the verge of something that's going to be totally different going forward, because there is such an incredible amount of interest in private industry and commercial companies. We've got an experiment ongoing right now with the commercial lunar payload services model for lunar exploration, where we aren't building the spacecraft and we aren't purchasing the launch and the delivery. We buy a service. And so it's been a really interesting experiment. We now have 7 of those on the books that are going to fly. We haven't had one fly yet, but hopefully maybe this year, we'll get some of those going. But it's a new way of thinking about how we get the science and do the work that we do as a science agency. So I think Mars is a really fertile ground to kind of build on some of those capabilities, not just taking advantage of the commercial capabilities that we're already doing, like things like SpaceX launches and things like that, but looking towards, are there models that are these kind of services models? There was just a low-cost Mars small mission workshop that was held a few weeks ago out at JPL with a lot of discussion about how can not just NASA and other agencies partnering together to build missions, but how can we also bring in commercial capabilities, either as procured things more traditionally, but also this kind of commercial model. Is there something, is there enough interest out there in the commercial sector to kind of become a sustained capability that we can buy services from, for example?
And if I may, just quickly, it opens up the trade space of possibilities, right?
Yeah.
There's so many more people to talk to and companies to talk to and ideas coming out, and some of the more non-traditional ideas as well. And so it's really forcing, I think, us as government to rethink how we're approaching things. So I think that's a big part of it. The other thing we need to remember is that part of government's job, or at least for us, is investing in our industries to make them commercially viable. And so here we are now, victims of our own success, because we've invested in these companies to build a space economy, and that space economy is now here, and it's growing. And so the question is, how do we deal with it, and how do we really utilize that for the future?
Thank you so much.
I think we've got Chris waiting in the wings here saying that our time is up. Oh, Janet, I saw you. I didn't see you creep up.
I don't have the shepherd's hook. It's fascinating stuff, but we do have a few other panels and stuff. Please give these esteemed guests, both virtually and in person here, a big round of applause.